This is a sensor that Stress-Tek designed in response to a request that we received to measure very small changes in motion in rocks over a period of time. The sensor was to be placed inside a cut in the rocks, and a flat jack went into this cut, and they applied pressure to the jack, which would put opposing forces trying to push the rocks apart, and they wanted to measure very small motions over a period of time due to the forces. And the issue was, where do you put a sensor when there's no room to put one? This is a very simple device, as it turns out, that we came up with. It's basically to measure deflection using 2 spring steel beams. Went from approximately 1/4 of an inch closed up to 3/4 of an inch open. Would measure linearly the gap, the change in gap between these 2 points. The jack was composed of 2 flat pieces of metal, and in resting state there was about a 1/4 inch gap between the 2 pieces of metal. And when it was pressurized, the metal would expand out to and up to 3/4 of an inch. So this sensor was designed to go inside the jack in the hydraulic oil. At rest, these little bumps on each end were the points that contacted the plates of the jack. The base end had a small hole in it. A small wire was placed through that on the mount, and that was the pivot to allow the sensor to self-center between the 2 plates. Other than putting half-bridge strain gauges on each side to measure the bending, we just requested that instead of using hydraulic oil in the jack, that they use a transformer oil, which has better electrical properties, again for the purposes of the strain gauges. So in use, obviously this device, whether it's under pressure or not inside the jack, had no effect on the bending of the beams. So it totally ignored pressure and was only responsive to the change in dimension at the end of the beam. I believe this part had a resolution of down to about 1/10,000th of an inch, and successfully used in a rock mechanics study.